Speaker for this session is Mr. Mangesh Pawar from Patwin Engineering Private Limited, and he is going to talk about the smart paint systems. He graduated from Pune University with a degree in mechanical engineering, and he is a veteran of fluid handling industry with a rich experience of more than 27 years. There was another person with similar experience.
But I don't look that old.
So many veterans are here. So we would hear from him about the smart solutions in the painting process. Thank you.
Thank you, Gupta ji, for the kind introduction. Thank you, CII. So, all of you, I don't know how I can make it engaging and entertaining now. I can see some people sleeping already at the fag end of the day. I mean, it's, I would say the earlier sessions got delayed, so we're behind schedule by about 45 minutes. I'll try to make it quick. And for more information, I think you can connect with us on stall 158. And I can only say one thing, that we can help you save money in your paint mix room, paint preparation, paint distribution systems, and in special color systems. I wanted to touch on the Piggable paint supply also, but I think I'll have to skip it due to the paucity of time and to free up you guys for the tea, coffee and cocktails thereafter. So this is about Patwin. It's a 37-year-old company, and I have been doing turnkey projects for paint circulation systems and sealer distribution systems since then. Our expertise is fluid handling, dispensing, metering, dosing, mixing, then some automation also in paint, sealer, and as I said, turnkey projects is what we deliver to our customers. So it's end-to-end solutions. We also have solutions throughout the entire manufacturing of the car body. So from press shop, body shop, paint shop, assembly, we do have something or the other that we supply for the manufacturing. So today I'm going to talk a little bit about the smart paint systems. I have touched based upon this subject a couple of times before as well on various forums. It's something dear to me and something that is our core business in Patwin. And there's always something new. It's something that we keep on ideating, innovating and adding. So it's kind of a modular system. So every time that you will see something new in the system or in my presentation or something we would have implemented in the recent past. So the smart paint system is basically smart temperature control, smart viscosity control, smart color demand, smart velocity, smart agitation, smart pressure monitoring, smart barcode systems for correct color loading so that the operators don't make mistake, because typically in India we have casual labors for this activity, and the smart management notifications on the smartphones. This is something about what we got through a survey of paint managers and what do they want. When they say the first time right is something, their highest priority is zero defects, dirt particle reduction, lint reduction, rundowns should be less, uncovered areas should be less, no paint craters, no spitting, etc. So some of those attributes are through the paint system. So a very well designed and a well balanced paint system will give lesser defects and lesser headache to the paint production facility. So these are some of the factors that contribute to paint qualities: the spray variables, paint variables, booth variables, movement variables, which is the conveyors, etc., and the vehicle variables itself. So the smart PCS will take care of the spray variables basically. So in the smart paint system, we maintain uniform viscosity by maintaining proper temperature on a real-time basis using advanced temperature control systems and a Patwin proprietary software that we have developed with algorithms which give a very close tolerance band on the temperature of the paint. Then we also have uniform viscosity with automatic online viscosity measurement and automatic dosing of solvents wherever required. Then meeting pressure and flow requirements for automatic and manual stations dynamically means only the pumps or the paints which are in production in the booth are at a higher pressure and are at a higher cycle speed, whereas all other will move to the non-production mode, thereby saving further energy. Then we also maintain the particle velocity in the entire pipelines right up to the hose that goes to the gun to ensure that there is no settling of paint and adding to any kind of dirt or any kind of shading effects that we normally see on the LH side of the car and the RH side of the car with some specific paints. So the suspension in the paint tank is done by smart agitation. Similarly, real-time pressure monitoring is done so that we know about the buildup of dirt in the filter and the time for filter change, so which can be planned during tea breaks, lunch breaks, etc. Then we have a smart barcode scanning system for ensuring correct paint loading, and a smart notification for all the alarms that will go to the stakeholders, the manager, the supervisor, etc. through SMS on their smartphones, or it can also be done through emails. This is the smart temperature control systems. These are pictures of actual installations, not just laboratory systems, where we have different types of settings for different paints individually can be controlled based on the calorific value of those paints. So we have a separate circuit for cold water and a separate one for hot water for precise control. Then the viscosity, as I mentioned, is the variations are online detected and correction is also made online. So it's completely closed loop and real time. This is how it looks typically. This is the architecture. You can see with the inline viscosity control, the tolerance band is very less. So this would typically give you lesser defects of rundowns and sags, etc. on the paint. Then this is the smart color demand control, which will be from the booth. From the robot control panel, we'll get a signal of which car bodies are coming in next for painting, and based on that, only those pumps will be in the high pressure and high cycle mode. So velocity control, so the velocity is maintained by smart control of pump cycles. So since the pump cylinder is a fixed volume cylinder, we are monitoring the velocity with the cycle rate measurement and then deriving a value of actual velocity through again a software that we have developed. This is about the agitation. So agitators are closed looped with the level monitoring systems, and as the level goes down, the agitation speed goes down so that there is less splashing, and also we can have a timer on the agitators to further reduce the energy consumption. This is how it looks. So at various tank levels, the agitator speed can be changed. This is again the pressure monitoring that we spoke about. With this, the pressure sensors would give an alarm or when there is dirt in the filter, and then you can take care of the filter. So it's again real time to avoid surprises or downtime in the line basically. So the filter change activity can be a planned activity instead of a reaction after it's clogged. So everybody is talking about digital industry 4.0, industry 5.0. So we can give a lot of data on quality, consumption, faults, alarms, etc. to a cloud in whatever format you want, or to your in-plant management system, complete, or your central process control room. All this can be provided. So every line can be monitored, so that the uptime and the OEE of the equipment that we supply will be much higher, because it will be under monitoring continuously and will be correcting on its own for most of the issues and errors. Show you the exact utility of each consumption of each this thing calendar wise. Similarly, the trend data and the preventive maintenance alarms. This is how the system architecture is. We also have leak detection control. So in case there is unfortunately any leak or any spillage, so we take preventive action and sending out alarms so that any accident can be avoided in the paint mix room, that being a hazardous area of category zone 1. So we have this kind of system as well. We can set up the complete timetable of operation of the system's production mode as well as non-production modes in the beginning itself, so that intervention throughout the day or the man movement throughout the day in the paint mix room, which can add to dirt, is minimum. As I said, self-diagnostics, everything is available. So by the way, this is not just a project. I mean, this is not just something that we have developed or just showing as a presentation. It is from real implemented projects, and we have done about 6 such projects right now already in India. Thank you.